Welcome back, dear children. We continue with our fourth chapter, carbon and its compounds. And today's topic is versatile nature of carbon. In the beginning of this chapter, we learned that carbon is an extremely versatile element. And in this class, we will see what are the reasons for the versatile nature of carbon. Versatile nature of carbon. What is the meaning of versatile? Carbon is capable of performing various functions. Carbon forms a very large number of compounds. Actually, the number of compounds formed by carbon is much more than the total number of compounds formed by the remaining 118 elements. That makes carbon special or unique. Okay. So, the reason why carbon forms a very large number of compounds or reason for the versatile nature of carbon we will discuss today. The first reason is the property of catenation. The first property is the property of catenation. Catenation is nothing but the ability of an element, to form bonds with its own atoms. The ability of an element to form bonds with its own atoms, that is carbon forming bonds with other carbon atoms. So, that self-linking property of an element, that is known as catenation. The definition of catenation you have to learn. The ability of an element to form bonds with its own atoms is known as catenation. Carbon has the unique ability to form bonds with other carbon atoms, giving rise to large molecules. Carbon has the unique ability to form bonds with other carbon atoms, giving rise to large molecules. So, carbon atoms can combine with one another, giving rise to long chains in different forms such as straight chains, branch chains, and closed chains or rings. Okay. So, the ability of an element to form bonds with its own atoms is known as catenation. Carbon has the unique ability to combine with other atoms of carbon, giving rise to large molecules. So, carbon atoms can combine with one another, giving rise to long chains in the form of straight chains, branch chains and closed chains. Now, we will see what is a straight chain, what is a branch chain and what is a closed chain. Now, how do we represent carbon? What is the valency of carbon? Valency of carbon is carbon has a valency of 4. Carbon has valency 4. Its electronic configuration is 2, 4. So, it has to either gain 4 electron or lose 4 electron to get the configuration of noble gas. But carbon doesn't share or doesn't lose or gain electron, instead it shares electron with other atoms. So, its valency is 4. So, this is how we always represent a carbon atom. These 4 lines represent the 4 valencies of carbon. So, these 4 lines, we are not simply drawing these 4 lines around carbon. Actually, these 4 lines represent the 4 valencies of carbon. These 4 valencies should be satisfied with either other carbon atoms or atoms of other non-metals like hydrogen, oxygen, chlorine, etc. First, we will see compounds formed with hydrogen. After that, we will move on to compounds of carbon formed with other elements. Okay, so this is how always around carbon there should be 4 lines. It need not be. These 4 lines are single bonds. We learned about single bonds, double bonds and triple bonds. Since carbon has 4 valencies, we can write all the these 4 bonds are single bonds now. But it can form double bonds as well as triple bonds too. Now I have drawn only single bonds around carbon, but always there should be 4 bonds only. If it is forming a double bond, then if one bond is a double bond, then only 2 more valencies left. So making the total valency 4. Is it clear to you? So these 4 lines represent the 4 valencies of carbon. So make sure that we never draw lines more than 4 around carbon. Okay. So first we will see a straight chain. How carbon forms a straight chain in combination with other carbon atoms. Carbon join with other carbon atoms, giving rise to straight chain molecule, long chains in straight chain. So 6 carbon atoms in a straight chain. Between the carbons, I have put single bonds. 4 carbon atoms which are joined together by single bonds. Now take the first carbon atom. Now its one valency is satisfied here with the second carbon atom. Now how many free valencies are there for carbon? 3 more. So draw 3 lines. Take the second carbon, 2 valencies are already satisfied. Draw 2 more. Third one also. On the left and right hand side of the third carbon atom, 2 valencies of carbon are satisfied. Now it has 2 more free valencies. Same way. I hope it is clear to you. Everywhere you can see that 4 valencies of carbon are satisfied. Now the last one has 3 free valencies. So 3 lines we have to draw. We call it as a carbon skeleton only. This is a skeleton. This is actually not a compound. Only when you draw other elements here, it becomes a molecule. It's a compound. Now it is just a skeleton. So this is a carbon skeleton in straight chain. It is a straight chain, isn't it? It's a straight chain where we have 6 carbon atoms. Okay. Carbon joins with other carbon atoms to form a long chain in straight chain, where all the 4 valencies of all the carbon atoms are satisfied. Writing like this is known as a carbon skeleton, where only the carbons are represented with their valencies. No other elements are shown. Okay. So this is a straight chain. Now with the same number of carbon atoms, I will draw a branch chain. So first I will draw 5 carbon atoms in straight chain, 5 carbon atoms in straight chain, and the 6th carbon as a branch. Okay, so 5 carbon atoms are in straight chain and the 5th one comes as a branch. We call it as a branched chain compound. Branched chain. So first one is straight chain, second one is branch chain. Now we can see that the valencies of carbon are not satisfied here. Take the first carbon atom. One valency is already satisfied. Now 3 more free valencies which you have to represent with single bonds. Now take the second carbon. 1, 2, 3. 3 valencies are already satisfied. So only 1 free valency it has. Third one, 2 valencies are satisfied. Draw 2 more single bonds. Fourth one also same way, 2 valencies. Last one, only 1 valency is satisfied. So you have to draw 3 valencies. 3 free valencies are to be represented. Now take this branched carbon. This is also a carbon atom which has valency 4. The carbon in the branch also has valency 4. Okay. So one valency is satisfied here. It has 3 free valencies which you have to represent. So this is a branched chain. Straight chain, all carbon atoms lying in a straight line. Here branch chain for 5 carbon atoms in a straight chain and 1 as a branch. Now the last one is closed chain. So these 2 compounds, straight chain and branch chain compounds, we call as open chain compounds. They are open chain. The chain is open on both the sides, isn't it? The chain is open on both the sides. So they are open chain compounds. Now comes the closed chain compound. Closed chain. Carbon can combine with other carbon atoms to form compounds in closed chain. So 6 carbon atoms. So 6 carbon atoms I have drawn. join them using single bonds. Join them using single bonds. Now look at the valencies of each carbon. First carbon has 2 valencies already satisfied, 2 more valencies are free. Draw the 2 valencies. Here also 2 valencies are free. Everywhere all the carbon atoms 2 valencies are satisfied and 2 free valencies you have to represent. Okay. So all the 6 carbon atoms have the 4 valencies satisfied. We call it as a closed chain or a ring or cyclic molecule. Closed chain, the chain is closed, it has no open ends. So it is called a closed chain or a ring or a cyclic molecule. Okay, so with the same number of carbon atoms, 6 carbon atoms, I have drawn 3 different structures: straight chains, branch chains and closed chains, ring or cyclic structures. So this is the unique ability of carbon to form bonds with its own atoms. So this is the example shown for 6 carbon atoms. So you can write examples with 5, 7, 8, 9, 10, more than 100 carbon atoms can be there in compounds of carbon. So as a result, what happens? The total number of compounds increases. Now in addition to this, carbon atoms may be linked by double or triple bonds. Here what I have shown you is chains with single bonds only, but carbon has 4 valencies. So carbon atoms can be joined by means of double bonds or triple bonds. So the compounds of carbon where there is a double bond between carbon atoms is not, where there is a double bond between double or triple bond between carbon atom is known as unsaturated compound. Unsaturated compounds. Compounds where carbon atoms are joined together by means of double or triple bond are known as unsaturated compounds, and only single bonds are there between carbon atom. If all the bonds are single bonds, we call them as saturated compounds. Okay. So saturated compounds and unsaturated compounds. In saturated compounds, all the bonds between carbon atoms are single bonds. In unsaturated compounds, carbon atoms may be linked by means of double bond or triple bond. One example I will show you for double bond and triple bond. Same 6 number of carbon atoms. 6. So one bond I will draw as double bond. So there are compounds where more than one double bond is there. Here one bond, only one bond I have shown as double bond. Now how to satisfy the other valencies? You have to be careful. Please see that always the valency of carbon is 4. So you have to be careful. You count the valencies, then draw the lines. First carbon, only one valency is satisfied. So 3 lines you have to draw, making the total valency of the first carbon 4. Now take the second carbon atom. Be careful. One valency on the left hand side, 2 valencies on the right hand side, making it 3. Now how many free valencies for this carbon? 1. Only one valency. Third one also 2 plus 1, 3. Only one valency is free. Then fourth and the fifth carbon atoms have 2 free valencies. Last one 3 free valencies are there. So this is an unsaturated compound. There is a double bond between carbon atoms. So this is unsaturated. Now with the same 6 carbon atoms, I will show you how a triple bond is formed. 6 carbon atoms in a straight line. One of the bond I will make triple bond. All the other bonds are single bonds. One of the bond, the double bond can be put anywhere depending upon the nature of the compound. Now I have put it between third and the fourth carbon atom. Okay. Now take the first carbon, 1 valency is occupied, 3 are free. Second carbon, 2 are occupied, 2 more valencies free. Now look at the third carbon atom. 1 valency on the left hand side, 3 valencies on the right hand side, making it 1 plus 3, 4. Now there is no more free valency. So, you cannot draw any line on this carbon atom. If you are drawing lines on this, your structure will be wrong because all the 4 valencies of this carbon are already satisfied. Same is the case with the 4th carbon also. 3 plus 1 making it 4. So, no free valencies for the 4th carbon atom. Coming to the 5th one, 2 valencies are free, and the last one, 3 valencies are free. Okay. So, this is how, this is also an unsaturated compound where there is a triple bond between carbon atoms. Okay. So, as a result, what happens? The total number of carbon atom keeps on increasing. So, this is one reason for the very large number of carbon compounds, formation of very large number of carbon compounds, or the versatile nature of carbon, the property of catenation, carbon linking with other carbon atoms, the self-linking property of carbon. Okay. Now, the second reason, tetravalency. What is the meaning of the term tetra? Tetra means 4. Carbon has a valency of 4. It is capable of bonding with 4 other atoms of carbon or atoms of non-metals like hydrogen. Carbon can form bonds with hydrogen, chlorine, oxygen, sulfur, nitrogen, etc. Okay, so carbon is capable of forming 4 bonds with other atoms of carbon or non-metals like hydrogen, chlorine, oxygen, sulfur, nitrogen, etc. One example I will show you. 4 valencies. This we have already seen, methane, where the 4 valencies of carbon are occupied by hydrogen atoms. We call it as methane. Now, from this methane, one hydrogen is replaced with a chlorine atom. Instead of one hydrogen, we call it as chloromethane. Not one carbon, one hydrogen atom. All the hydrogens can be replaced with chlorine, and we can write it as, so if one hydrogen is replaced, we call it as chloromethane. Now, all the hydrogens can be replaced with chlorine. We call it as carbon tetrachloride. This is an organic solvent, carbon tetrachloride. So, carbon can form bonds not only with other carbon atoms, it can form bonds with elements of other non-metals like hydrogen, chlorine, oxygen, nitrogen, etc. Okay. So, this gives rise to a large number of compounds with specific properties. All these are different compounds. They have their own specific properties, and the bonds formed with other elements are very strong, and the compounds formed are exceptionally stable. The compounds formed are exceptionally stable. So, that is tetravalency. Carbon is capable of, valency of carbon is 4. So, it is capable of forming 4 bonds with either other carbon atoms or atoms of non-metals like hydrogen, chlorine, oxygen, nitrogen, sulfur, etc. So, this gives rise to a very large number of compounds with specific properties. The bonds formed with other elements are very strong, and the compounds formed are exceptionally stable. So, that is all. Thank you, children.